Hello everyone! In this video, we'll take a quick deep dive into Python. We'll talk about how Python works, its basics, history, and where it's used. Let's get started. Python is an interpreted language, which means that instead of being compiled like C++ or Java, Python code is executed line by line by an interpreter. This makes it easy to test code in small chunks and quickly identify issues. Python is a versatile language, widely used in areas such as web development, data science, automation, artificial intelligence, and even game development. Its flexibility makes it ideal for both beginners and experienced developers. A key strength of Python is its simplicity and readability. The syntax is designed to be intuitive, allowing developers to focus more on solving problems rather than getting lost in complex code structures. Python uses significant white space, meaning indentation isn't just for style, it's a requirement to define the structure of the code. This ensures that Python code is always clean, organized, and easy to read. Another reason for Python's popularity is its extensive libraries. From NumPy for data analysis to TensorFlow for machine learning, Python has libraries for almost everything. Python is also used in popular applications. It powers websites like YouTube and Instagram, and it's essential for tools like Spotify and Dropbox. Its versatility and ease of use make Python a favorite among developers worldwide. Python has become one of the most popular programming languages in the world, consistently ranking at the top of developer surveys. Its combination of ease of use, versatility, and extensive library support has made it a favorite across industries and fields. When it comes to developer usage, Python attracts both beginners and seasoned developers. Whether someone is building a simple automation script or a complex AI model, Python offers the right tools and flexibility. It's also widely used in academia for teaching programming concepts due to its simple syntax. Python's adaptability is another key factor in its success. It supports multiple paradigms, including object-oriented, functional, and procedural programming, making it suitable for a variety of projects, no matter the size or complexity. Many industry leaders rely heavily on Python. Companies like Google, Microsoft, Facebook, and Netflix use Python for tasks ranging from back-end development to data analysis and machine learning. Its ability to integrate seamlessly with other technologies further boosts its appeal. Python shines across numerous industry applications, including web development, scientific computing, data science, machine learning, automation, game development, and even cybersecurity. With such a broad reach, it's clear why Python continues to dominate the programming landscape. To truly grasp Python's power, we must understand its interpreter. Unlike compiled languages, Python uses an interpreter to execute code. This means that when you run a Python program, the interpreter reads and executes the code line by line. This line-by-line reading allows for quick testing and debugging, making it easy to identify issues as they arise. You can run a single line or a few lines of code without needing to compile the entire program, which is particularly useful during development. Another significant feature of Python's interpreter is dynamic typing. You don't need to declare variable types explicitly. Instead, the interpreter determines the type at runtime. This makes coding faster and more flexible, allowing developers to focus more on logic than on strict type definitions. Memory management in Python is also handled by the interpreter. It automatically manages memory allocation and deallocation, which helps prevent memory leaks. Python uses a technique called reference counting and has a built-in garbage collector to reclaim memory that is no longer in use. All of these features contribute to development efficiency. Because the interpreter simplifies tasks like debugging and memory management, developers can write and maintain code more effectively. This leads to faster development cycles and helps bring projects to life more quickly. Control flow structures are essential in any programming language, and Python is no exception. They determine the direction in which a program executes based on certain conditions. Let's explore the three main control flow structures in Python: if statements, loops, and functions. First, we have if statements. They allow you to execute code conditionally. For example, you might want to perform a specific action only if a particular condition is met. This provides flexibility in how your program responds to different inputs. Python supports elif, else if, and else clauses, allowing for multiple conditions to be checked sequentially. Next up are loops. In Python, we mainly use two types of loops, the for loop and the while loop. The for loop iterates over a sequence, like a list or a range of numbers, executing a block of code for each element. The while loop, on the other hand, continues executing as long as a specified condition is true. Loops are powerful tools for automating repetitive tasks and iterating over data collections. Finally, we have functions. Functions are reusable blocks of code that perform a specific task. You define a function once and can call it multiple times with different inputs. This helps to keep your code organized, modular, and easier to maintain. Python also supports Lambda functions, which are small anonymous functions, adding further flexibility. To appreciate Python fully, it's essential to understand its history and evolution. Python was created by Guido van Rossum, and its first version was released in 1991. Guido aimed to design a language that was easy to read and fun to use, which is reflected in Python's clean syntax and intuitive design. The initial release laid the foundation for what would become one of the most widely used programming languages in the world. In 2000, Python 2 was introduced, bringing significant improvements and additional features. This version made Python more robust and suitable for various applications, establishing it as a serious contender among programming languages. Python 2 became popular in the industry, with many developers adopting it for web development, automation, and data analysis. Then came 2008, marking the release of Python 3. This version aimed to rectify design flaws in Python 2 and introduce a more consistent syntax. However, it wasn't backward compatible, which meant that some code written for Python 2 would not run in Python 3 without modifications. Despite initial resistance from some developers, Python 3 eventually became the standard, incorporating many powerful features and enhancing the language's usability. Since then, Python has continued to evolve, with regular updates and an ever-growing community contributing to its extensive library ecosystem. Today, Python stands at the forefront of programming languages, used in diverse fields from web development to data science and machine learning. Python plays a crucial role in modern technology, making significant contributions across various domains. Let's explore three key areas where Python excels: artificial intelligence, web development, and data science. First, in the realm of artificial intelligence, AI, Python has become the go-to language for developing intelligent systems. Its simplicity and readability make it an ideal choice for researchers and developers alike. Libraries like TensorFlow, Keras, and PyTorch provide powerful tools for building machine learning and deep learning models. Python enables rapid prototyping and experimentation, making it easier to turn innovative ideas into reality. Next, in web development, Python has gained popularity due to its frameworks like Django and Flask. These frameworks allow developers to create robust and scalable web applications quickly. Python's clean syntax and extensive libraries streamline development processes, enabling the creation of everything from simple websites to complex web services. Its versatility in web development makes it a favorite among startups and established companies alike. Lastly, in the field of data science, Python is a dominant force. It offers powerful libraries such as Pandas, NumPy, and Matplotlib that facilitate data manipulation, analysis, and visualization. Data scientists use Python to extract insights from data, perform statistical analyses, and create visual representations. With its ability to handle large datasets and perform complex computations, Python has become indispensable for data-driven decision-making in businesses. In summary, Python's versatility and ease of use make it a vital player in the advancement of artificial intelligence, web development, and data science, helping drive innovation in modern technology.